So I'm wearing my shirt from when I worked at Amazon Web Services uh, as a dedicated blockchain specialist. What I'm going to show you right now is the actual building blocks of blockchain, and they're running in a browser right now. With each letter, you'll notice that the hash changes. What will the world look like when we've replaced these centralized feudalistic havens for our data and for our social media with user-owned alternatives that are incentivized by the token utility that is built into the various blockchain networks that run them. So I was asked today to speak about blockchain technology. So I'm wearing my shirt from when I worked at Amazon Web Services as a dedicated blockchain specialist. And I'm going to try to share with you a few ideas. But before we get into the technical details, I want to share some fun advertisements that Coinbase has released recently that I think help to convey some of the benefits of blockchain and crypto to everyday people. So here we go. I'm going to share my screen here and share the sound as well.
Hey, Earl.
Hey, Bill.
Crypto wasn't for him. He'd steer you clear of the drywall screws when what you really needed were concrete anchors.
Thanks.
That one.
This one?
The small one, yeah, that one.
But when it came time to settle up,
I don't have any cash.
the register signs didn't register. How could those swipes be worth 3% of his profit? But then part-time cashier / full-time grandson had another idea.
Can I come in?
Crypto payments. Lower fees, less paperwork, more profit.
Thank you.
Thanks.
Turns out it's the right tool for the job. Crypto wasn't for him until it was.
I'm going to load up another one here. So there we saw an example of a shopkeeper, right? And some of the potential benefits of crypto for them. Does anyone recall what those benefits were?
Less paperwork, more profit.
Yep. So you probably know that when, and this is very much the case here in the States, that people don't tend to carry much cash on them. I know that's probably different in Africa, because in Africa, there are a lot of folks who don't operate from a bank account as much, right? But I've heard that mobile payments are really big in Africa, and I know that I think in Kenya, particularly, the M-Pesa was really big, right? Is that right?
Mm-hmm.
Yeah.
And so this notion of using your phone, I bet you a lot of folks don't carry quite as much cash as they used to because they just use their phone, right? Is that the case in Kenya?
Yeah, especially during COVID, because everybody had a payable number, and yeah, like handling cash, like we thought that was how you spread the contagion.
Dangerous. Yeah. Dangerous because you're spreading the virus, right? Okay. Yeah, that's cool. So there's some similarities there, even for your jurisdiction. I'm going to play another one here. Oh, let's see. We got someone else joining. All right, here we go. This is the second ad.
Crypto wasn't for her. She could tell her remote to record her favorite show, but crypto,
Record Crimson Falls.
not her thing. That is until her son lost his wallet and needed a place to stay.
You lost it?
International wire transfers don't exactly move at the speed of concerned parent. Maybe that's why Jake's idea didn't seem so far-fetched.
Hey, send
If
it.
she could get a few $100 down to Cabo in no time flat, well, sign her up. Crypto wasn't for her until it was.
Okay, so there we have an example of international payments that need to get somewhere fast, right? So sometimes folks who are concerned about crypto and the fact that the transactions are irreversible are like, well, what if someone, what if I don't know who I'm dealing with? What, I'm sending the money across a border, and if somehow this is a mistake, how do I get it back, right? Well, if it's an honest person you're dealing with and it was a mistake, they can just return the funds back to you, right? But one thing that I didn't actually know until I worked more closely with the banking system is that international wires are also not reversible. Basically, you send an international wire and if it's a mistake and the person does not want to return the funds, you're out of luck. That's just so really the existing banking system is no better, and in fact it's worse because it takes like a couple days typically for a bank wire to arrive. Maybe you request it on one day, I get a call back from my bank on later on that day in the afternoon. If I made the cutoff, if I didn't make the cutoff, they don't call me until the next day. And then it goes out in maybe 1 or 2 batches that they have in the given day. But then the other bank receives it later on that day and may not fully acknowledge the receipt of the funds until the following day or something. So as you can see, our existing banking system is pretty slow, but crypto, as you may already know, even the slowest crypto transactions arrive within about 10 minutes. So that's another use case. Any comments on that? All right, let me jump into this third one.
Crypto wasn't for him. He dealt the classics. Low miles, big blocks and bench seats, hidden gems in dusty barns, diamonds in the rough. He'd take fixer-uppers and turn them into daily drivers. But when it came time to make a sale, there were no easy options. He never could figure out why wire transfers took so long. Banks were never open when he needed them. And cash, well, cash could be a challenge in a place like this. So when a repeat buyer mentioned another option, he listened. Just a simple transfer, secure, like a digital handshake. Crypto wasn't for him, until it was.
All right, what did you guys think of that one?
When you talk about the cash was not like a good idea on this environment, it's kind of reminded me the day that I destroyed $100 bill because it was stuck in my trouser zip. So,
Oh,
so definitely crypto needs to be there.
yeah. Well, I won't ask you how you managed to get $100 bill in your zipper, but anyway.
Oh,
Like the pockets inside got stuck to the
Oh,
zipper. So.
okay, I got you.
I was gonna say I feel sorry for you whoever like got that $100.
Yeah, I
I
sometimes
love. I was gonna
sometimes
say I love the yodeling. Yeah. So Carla, I got a question for you. Like,
okay.
and that I guess was clear. Like, in terms of like safety, cybersecurity. I know like bank wires can be intercepted, but like,
Yeah.
why is crypto so safe? And like better than the traditional banking methods, like decentralized banking. Like, why is that so reliable?
Yeah, that's an interesting question. I hadn't actually thought of presenting on this today, but maybe I can, if I can remember, there's this really great website. I am going to show you guys today a short demo of how a blockchain works. So one thing I love about those ads, but though, before we leave them, is they're focused on everyday people, right? Not people who are highly technical. And I like that they're trying to demonstrate that we're already in a phase where we're past the adoption curve of the geeks and the nerds, right? We're now seeing folks who are everyday people who are interested in blockchain. So I'm gonna let's see, I'm gonna also paste the link to this demo in the chat so that anyone who wants to look at this or study it in depth later can do so. You'll notice that he has an actual some YouTube videos on this website where he walks through these things to show you kind of how they work. But I will do it step by step with you guys today. So what I'm going to show you right now is the actual building blocks of blockchain, and they're running in a browser right now as a demonstration of how a blockchain works. So one of the first building blocks that's really core to the functionality of blockchain is what we call a hash function. Sometimes it's called a digest function, but the purpose of a digest or hash function, it's a function in cryptography that will take any message, no matter how big or small, and convert that message into a fixed length random string. And that string is very difficult to guess. You pretty much could never guess which piece of data would produce which random string. It's also designed not to avoid what we call collisions. This means that if I have two sentences that are very similar but slightly different, they should still produce a completely different random sequence of letters and numbers, right? So I'm going to show you how that works now. So an empty string in this particular SHA-256 hash function, there are different flavors of hash function. This one's called SHA-256. It stands for like security something or other. I forget. There's a famous organization, SHA. I'm forgetting the acronym at the moment. Secure Hash Algorithm. So that is the what that stands for. So this is a particular standard that is approved by a standards body. But the empty string comes out to this code here. But if I start typing, with each letter, you'll notice that the hash changes. I'm adding exclamation points. And with each one that I add, as you can see, the string that it produces is truly random. You could not predict what this string would be. I'm going to just bump up my font so you can see it a little better. So this is one of the main building blocks. And it could take a very large string as well. If I paste a whole website into here, the hash is running over that entire string, right? So that's one of the first building blocks, is this secure hash algorithm, this ability to take any data and convert it to a fixed length random string, right? Now, we'll see how that works, how that fits into the big picture later, okay? The next thing we want to look at is a block, all right? So a block is very, it's really not doing a whole lot more than what we just saw. It has a number assigned to it, and that number is always incrementing. So it starts at number 1 and it increases with each block. And a block has what we call a nonce that's kind of just designed to add a little bit of identifiability to this block, an ID we can use to refer to the block, and it introduces a little bit of extra randomness to the block as well. Nonces are typically used so that if, let's say I'm proposing many different blocks, like let's say we have more than one block with the same ID number 1, I can use a nonce to make it truly unique. And then a block is going to have some data in it. It might say something like Alice sent a certain amount of money to Bob, and the amount of money she sent could have been, let's say, 500 tokens, whatever those happen to be, right? And then you could have another one that says Bob sent some funds to Charlie, and a certain number of funds went there as well. You'll notice that as I'm adding information to this block, the hash here is changing with each character that I add. And if I change the nonce as well, like let's say the nonce is something different, or the block number is different, you'll notice the hash also changes. So that same property that I showed you earlier, where each modification to this overall data set modifies the fixed length random string, is happening here. So you see how we're using the hash. All we're doing is we're saying, instead of just hashing a generic sequence, I want you to track also a block number and a nonce along with whatever data I provide, right? Now the data in the block payload can vary. You know, your protocol, you might start some kind of a blockchain protocol that holds different kinds of data in the block payload. But the point is that no matter what data is there, we end up with a unique hash for each block in the sequence. Now, there is this concept of mining here, all right? And what mining is it will be finding a number that when combined with this, the rest of this data produces an expected result. So I'm going to click mine right now. And what this does is it essentially says, I need to come up with a specific number that when combined with, I'm trying to remember the details here, when combined with the rest of this block produces a hash where the first so many characters of the hash are 0. All right, so this is a unique kind of, this is where what we call proof of work comes in. This is how the Bitcoin blockchain works. So it's saying, I don't just want any hash. I want to find a hash that has this weird property that the first 4 characters of the hash are 0. Right? So if I add some extra stuff to this and I say like, Charlie sent some funds to Alice, suddenly I no longer have the nonce correct. Like you'll see that this hash is just an ordinary hash without the prepended zeros on it. So if I want to do the work of figuring out what nonce, when combined with this data and this block number, produces a hash with 4 preceding zeros, I will need to search through, I'll just need to try whatever numbers I can try. I may need to try hundreds of thousands of numbers before I get the right number, right? So I'm going to do mining again, and I found that it just so happens that this nonce 135064, this nonce, when combined with this data, produces a hash that has 4 zeros in the front of it. All right. Now, let's say that so maybe those 4 zeros are enough for, like, if I'm running a blockchain with only 100 people. But if I'm running a blockchain with millions of people, suddenly it's a little bit too easy to do the work to find the hash that has 4 zeros in front of it. So I could maybe up the stakes and make it harder. And the way I would do that is I would say I need a hash with 8 zeros in front of it, right? I can't demonstrate that with this example because it's hard coded to always do 4 zeros, but this gives you an idea of how some computational effort is required in this particular blockchain demo for a person to earn the right to receive a reward for that particular block in the blockchain. And so the way that in Bitcoin, the way that funds accrue to different individuals is that they do the proof of work necessary by demonstrating a nonce that, when combined with the proposed transaction list in the payload, produces this weird kind of hash that has 4 zeros in front of it. So now let's see how that fits into a blockchain. So in a blockchain, we now have the only thing we're going to add to this blockchain is that we're going to connect blocks together. So now, instead of having one block that's just isolated by itself, we have blocks in a sequence, and each block keeps track of what the next block is and what the previous block is. So we have here, for block number 1, we have no previous block. It's all zeros, right? And we could add some data to this very first block and say, Carl sent some money to Screven. Let's say sent you 50 Bitcoins, you can retire. So, and then let's say somebody mines that block, right? They found the nonce that produces the hash that starts with 4 zeros, right? Then we have another block, and people are going to propose transactions for this block. They're going to say, I want to send some money. So Screven says, well, I've got enough money. I'm going to send something to Jonathan because I'm just feeling generous. So he sends you 1 Bitcoin, all right? And someone else is running the blockchain network, and they mine this block. They find the right nonce, and they produce the expected hash, and they get a reward for doing that, right? But you'll notice that there's this interesting property here, right? Because I already had this previous hash listed, I had to come up with that's unchangeable. That's sort of set in stone. This first block has already been accepted into the blockchain, and so it can't change. If somebody tries to falsify history and add data, you'll notice that now it broke the chain, because this hash here no longer matches this hash here. At least they no longer are valid blocks, right? So if I then want to do the work of recreating a new set of history, I'd have to mine each of those blocks in turn before I could before I could essentially falsify the history of that blockchain. Now, on this little demo, it only is taking like a few seconds to do the work to calculate valid blocks. But nowadays, it takes like supercomputers many hours to do the computation for a single block reward. And the types of hash they need to find are like a needle in a haystack. They're like extremely, extremely hard. to find, right? But what I want to convey with this demo here is just that as I add data to the blockchain, they have a way of tying each block to the previous block. So you see that this previous code here has to match this one here. And this previous code here has to match this one here. And this one has to match this one, and so on and so forth. So you see that we now have this chain of blocks going all the way back to the very first block that was produced, right? And if anyone tries to slip in something, let's say Zachariah is feeling a little devious today, and he's like, guess what, guys? Screven didn't actually send his funds to Jonathan. He sent them to me, right? So now Zachariah has to prove that. So he has to do all this extra work, and he has to like probably rent data centers full of computers to do this work, you know? And in order to pull a fast one on people. And then he still has to like fool everyone long enough to withdraw the funds from Coinbase or the bank account or whatever before he gets caught, right? So anyway, you can see that's difficult to pull off. Now, that's a basic overview of blockchain, but let me go one step further here. So what's actually happening with blockchain is not only do you have these blocks that I showed you guys already, but you have multiple peers in a peer-to-peer network, and each of them has a copy of the same blockchain, right? So what happens is in one of these, you know, Jonathan, let's say he sends funds to Screven. And let's say he does all this effort to like prove that his blockchain is a valid blockchain, right? But let's say that all the other peers have a different history, and theirs says that instead of Jonathan sending funds to Screven actually sent the funds to Sharon. So if all the other, let's say all the other peers have this history, right? Someone who wants to prove that, like, if they want to forge something and fake it and like say that a different set of events happened than the ones that the rest of the world believes, then they have to demonstrate an alternate history and do all the work for that alternate history. And they have to go back as far back in time as they need to convince everyone that alternate history is true, right? And for this reason, sometimes different exchanges will wait several minutes before they will release the funds to you, because they want to let more blocks accumulate to make sure that you actually, that nothing weird happened and no one was forging blockchains, you know? So what this phase of the demo, this fourth phase of the demo is designed to do is to demonstrate to you how not only do you have a single computer with this history on it, you have many computers all with the same history, providing a kind of redundancy so that lots of different, if anyone loses the history, it's okay because lots of different other computers have it. So it might seem like a waste. Some people ask, well, why do we have so much data on the blockchain? Right now, it's like the Bitcoin blockchain is terabytes of data. Same with Ethereum. Why are we storing terabytes of data on every single computer that runs this node, right? Well, the purpose is security and not saving space. We're not trying to save disk space. We're trying to make it secure, right? So that's why we're wasting all that space. Now, these last phases just kind of give you more detail about how this works, right? They show that, you know, that what this payload is actually a ledger. Let me shrink this just a bit so we can see it better. It's actually a ledger showing that a certain amount of funds were sent from this individual to this individual. And each ledger sort of looks like that and has these details. So, but really that payload can contain whatever you want it to. A blockchain can contain, it can be used for any kind of transfer of data that you want to be secure. And so you'll see some companies are even starting to put elections on blockchain, where they'll like maybe scan ballots and then anchor the ballots to a blockchain by putting a hash of the ballot to the blockchain. Anything you want to add in the comment of a blockchain transaction is permanent. It's there for life. And so you could say, on such and such a date, Jonathan promised me that he would buy me lunch for the next 100 days, right? And you both sign on it, you both shake hands, and you say, but I want to be able to prove to the whole world that you promised me this. Maybe you make a YouTube video where Jonathan's recording it, and then you anchor the YouTube link to the blockchain, something like that, right? Then you can point to that and say, hey, back on such and such a date, Jonathan promised me lunch for the next 100 days, right? And you can do that you can anchor that to a blockchain, and it makes it that much more convincing to other people. We have a question from Ongoli, or Victor. Victor, go ahead, Victor.
Yeah, it's Sylvester, my phone went off. Sorry for that.
Oh, okay, gotcha. Sylvester, hi.
Yes, we just gathered here. So I was asking in regards to blockchain, which works through a lot of applications like Binance, OKX that I know, and actually using those kind of applications. Is there like let me maybe ask it this in this manner? Is there someone that is that is put as a customer service, something like that? Because most of the time you realize that once they are made in a way that once the transaction has been made, there is no reverse. Sometimes you can't do the reverse in most cases. So how does it go about?
That's absolutely right. So as I said, even international bank wires are irreversible. So you would have the same problem if you accidentally sent money to the wrong person. If that person doesn't want to give it back to you, then you're out of luck in a traditional bank or in a blockchain. However, there are many other things that can go wrong besides you accidentally sending funds to the wrong person. If you send funds to the wrong person, and you do it through just a wallet that no place like Binance or Coinbase or any of those other exchanges is using, it's just a private transaction, you really don't have any recourse in that situation, other than trying to persuade that person to refund you if it was just an honest mistake. Now, you might have trouble even getting a hold of them. And if you typed in their address wrong, it might be the case that nobody can get those funds because it's just sent to a random address that does not exist, that nobody has the private key for.
Yeah, just to interrupt, sorry for that. When you talked about wrong address, actually there were multiple times you send when you are doing like Binance transactions, they will give you a limit and they will say you must send above maybe $10, and sometimes you send below it, it just disappears. I was wondering to know, where does that even go? Because you'll never get it back. Where does it go?
So if you send a small amount, on most blockchains, you can specify very tiny amounts if you want to. Now, the thing is, you're talking about an exchange. I just want to make this clear. In crypto, we have this saying that people often say, where they say, not your wallet, not your funds. Okay? What this means is if you're relying on Binance to do something, they can do whatever they want. You're not dealing in that case with the blockchain directly. You're dealing with an intermediary who is taking your funds and then doing something with them that you ask them to do. All right. So in that particular case, Binance may say, well, we're losing money when we try to do transactions that are lower than a certain amount. So we don't want to allow that, right? The blockchain will let you do that, but Binance might not. Okay, so that's the first thing I want to make clear. Blockchains charge a transaction fee as well. All right. So blockchains may charge you more than the transaction is worth to send it to someone. So you want to make sure that you're sending enough funds that it's worth the transaction fee. Most blockchains nowadays have greatly reduced their fees, but there are some cases where you might still want to keep your transaction size large in order to not have so much overhead in terms of fees. In general, Sylvester, if you send a small amount, it will arrive at the other end if you're not on Binance. I don't know what happens on Binance though. If you know. Yeah, go ahead, Screven.
Yeah, so I like that little saying. So not your wallet, not your funds. But like
Yeah.
So are you implying that wallets can be hacked? Like I did hear like there's some of these wallets like Coinbase has had data breaches, right? So and people have lost their crypto. But the
Well,
blockchain is different. Yeah. Uh-huh.
in the case of Coinbase, what's usually happening and what happened most recently, if you watched any of their statements about this, is that they've got this weird challenge that crypto is very cyclical. And so what this means is that it's boom and bust, feast or famine. Sometimes they're hardly making any money, and sometimes they're making tons of money. And it just depends on whether the crypto market is going well right now. And so when they're not making a lot of money, they can't afford to keep the same customer service representatives on staff. So Coinbase has this strategy of hiring third parties to help them provide support, right? And relying on staffing companies that will like boost their support team when they need it and then reduce it later. But the problem is that the support team needs some access to people's accounts in order to even help people, right? And what happens is, when you're dealing with people who aren't paid a whole lot for providing support, then there can be a vector for attack. And what happened in this case is some people bribed some third-party customer support reps that were doing work for Coinbase, and they essentially fooled people into sending money places that they weren't supposed to, right? But it's important to clarify that no cryptography was broken in this process. No, nothing in terms of even wallets were hacked. It was all what we call a social engineering attack, right? A social engineering attack is where someone the weak link is always a human, right? So, sometimes you just put on a security vest and everyone thinks you're supposed to be there, right? Or sometimes somebody, a beautiful person, sweet talks the secretary, and all of a sudden she's giving up company information that she's not supposed to, right? So these are the kinds of challenges that it usually comes down to. And that in this case with Coinbase, that was a similar thing where people were getting text messages saying your funds are at risk, you need to call us now. And it turns out that in the process, they were they were siphoning people's funds away from them, right? And in this case, Coinbase has made good by refunding some customers who were hacked this way. And they've also created a reward to try to locate the hackers who perpetrated this fraud. So yeah, that's kind of what happened most recently with Coinbase. I'm going to show you one last thing here. So Coinbase is gets their name from this term that's in the actual Bitcoin blockchain. And what this is just saying, like, this final piece of the puzzle that I wanted to show you guys is that the Bitcoin blockchain also gives a reward. It pays a reward to whoever guessed the right nonce for the block first. So there's this contest whenever there's a new set of transactions proposed in a given block. Everybody, basically all the nodes across the world, say, I want to send this money to this person, and someone else says, I want to send it to this person, and we keep taking more transactions until a certain cutoff point. And those proposed transactions then are added to the upcoming block, and whoever can find the right nonce for that block first and broadcast it to the rest of the network gets rewarded for doing so. And that's what this Coinbase is. In the olden days, the very earliest days of Bitcoin, people earned 50 Bitcoin for each block that they earned that they could essentially decipher the best nonce for. And I was mining Bitcoins on a laptop back in 2010, okay? Sadly, I lost my wallet, so what was it? I guess now at this phase, I had 250 Bitcoins, so that would be $25 million worth of Bitcoins. I lost all that, right? But anyway, I have a fun story to tell about it. But I put the Bitcoin client on 4 or 5 computers at work that were not doing anything. And I came back to them a month later, and each one had 50 Bitcoins on it. So I consolidated all these coins into a single wallet. And back in that day, a single laptop computer could do enough work to mine Bitcoins. But over the years, that's gotten more and more difficult. They've had to add more zeros to the hashes in order to make it hard enough for people to compete in mining. And also they've had to reduce the reward amount. So with each 2 or 3 years, there's what we call a halving. They have the amount of reward that is paid. So now it's less than a single Bitcoin gets paid for each block that is solved, right? Or it's a very small amount. I don't remember the exact amount. It's like around a single Bitcoin, but I don't remember the exact amount. So Bitcoin is an inflationary protocol in the sense that they want to incentivize the work that is being done by paying a reward for each new block that is issued. But they do have a cap of like an overall number of rewards that will be paid out. And that reward that cap is 21 million Bitcoins. And so in like the year 2100, no more rewards will be paid. But I don't want to get into too much detail, but the incentive there is for people to do the work necessary to keep the blockchain secure, right? The only way someone can fake the history is by assuming more than 51% of the total computational capacity of the entire network. So you basically have to launch an enormous data center full of servers, and you'd have to have a lot of hardware to do that. So this little demo here gives you like the details, the basic details of how things work. And as I said, I pasted this into the chat so you guys can play around with it and watch the videos that are on that as well. If you want to, like study it some more. I think this is a great demo because it's actually kind of a simple set of tools, right? And it's pretty cool, the people who first came up with this idea, and it took them like some of these cryptographers like a decade or two because they not only had to be good at crypto, but they also had to think about it from the perspective of like monetary policy and economics. And so you had to, it was sort of this unique combination of talents to put together before someone came up with all this. All right, so
Yeah, Carl, this is fascinating. I can stay here hear you speak about Bitcoin forever. So
okay, all right, cool. So what I'd like to share with you guys today is like where I think this gets really cool. But before I do that, I did want to apply this to Africa a little in more detail and just mention 3 use cases I think are especially beneficial for Africa so that this is more applicable. So banking the unbanked is a big one. And I think that was demonstrated in those ads that we looked at, right? The people who are not really using crypto right now, I mean, maybe they had banks, but especially in Africa, you still have a significant number of people who, what's weird is like some of them are using their phone for transactions, but they still don't have a bank account. And this sometimes causes problems around like being able to take out a loan or different kinds of things like that. So as crypto becomes more sophisticated and provides all the services that the traditional finances could do previously, it essentially is bridging that gap. Excuse me. And there's actually a specific company called Bridge that just got acquired by Stripe. Let me just pull up one quick thing here. And what Bridge does, which is really interesting, is that they provide they can provide anyone with an ACH routing and account number, which is the way that our funds move around in the US. So you could have a crypto wallet, you could live in Africa, some other country, and they could associate an actual bank account, a routing account, and a routing number and an account number for your bank. And anytime someone deposits funds into that routing and account number, they arrive in your crypto wallet. Jonathan and I tested this, and sadly, it doesn't appear to be available yet in some African countries, but there are some who can get it already. And hopefully they'll be adding more soon. But what this means is like you could get hired, if you had the right skills, you could get hired by a US company and they would have 0 friction trying to pay you because they would just use the same method they've always used. They would not have to do any kind of pay any kind of fees or weirdness other than whatever minimal blockchain fees are already applied to the transaction itself. So it's very it greatly reduces friction, and pretty soon I've been told that they're also going to provide debiting abilities. So like in addition to allowing people to deposit funds on that account number, you could set up an automatic withdrawal on the account number as well. Once they have that running, I think I might actually just not use my bank anymore and actually just go straight in and out of my crypto wallets. And the reason for that is I can earn 10 to 15% per year on my savings accounts that are in crypto. Whereas if I'm at a regular bank here in the US, my interest rate is more like 4%. And it was even lower back before inflation was as bad as it is today. But as you can see, that that could be really a real game changer, especially for folks who don't live in places where it's quite as easy to get a bank account. And also a game changer just in terms of like being able to earn good yields on your funds, and also being able to hold your funds in a currency that you trust. That's where I think one of the biggest benefits to Africa is in what we call stable coins. So stable coins, the idea here is that instead of transacting in like Bitcoin or Ethereum or some of the other volatile cryptocurrencies, you can just receive your payment in dollars. And even though dollars are inflated, they're not inflated nearly as rapidly as some other currencies. And so having your payment in dollar gives you a little more savings power, you know? It looks like the only folks left are you and Jonathan Screven. So, I mean, I can keep going, but I don't, and we can share this recording with the rest of the meetup after this is all done. Maybe Jonathan can share it. One final thing is around identity. I think this is another really interesting use case. You know, folks who need to be able to prove who they are, maybe to associate some transactions or history with their identity. That could be another really valid use case for Africa as well, so that people can build a solid reputation and maybe be able to borrow funds and those kind of things. So those are some potential use cases, but I'm going to share with the rest of the time we have, I'm going to share something that I think is far more exciting than just the financial use case. And so let me see if I can do this. I need to switch which screen is being shared. Just a minute. Okay. So you should just be seeing my first slide here. Is that right?
Mhm.
Yeah.
Okay. All right. So I'm going to talk about where all this is going and how really blockchain technology will eventually replace the current internet. And to preface my remarks, I'm going to share a funny story about how you've been working for too long when you Google how to solve a problem and you find yourself asking the same question on the internet and getting the answer. And this actually happened to me a long time ago, where I said, will we ever get to a point where the core protocols are robust and secure enough that surveillance and centralized control of the internet becomes effectively infeasible? This was on an information security Substack, or not Substack, Stack Overflow, which is a place where people ask questions and get answers. Sadly, they've been suffering lately with the AI boom because so many people are asking their questions to AI instead of people nowadays, but they still have some traffic. But I found myself in the year 2014 asking this question several years later when I was preparing this talk. And so it's kind of funny to think about that. But this question is really related to the protocols of the internet. I wanted to know when we're going to get protocols that are really robust, really tamper-proof, and really can preserve your privacy. And there's a long, hard road to get there. And so a lot of startups in the blockchain space sometimes find that they have to create 3 or 4 other startups before they can even do the startup that they wanted to do, because the things just haven't been built yet. That's getting better, and we're starting to see some cool stuff happening. So what I'm going to talk about now is all of the aspects of the current internet that have problems and that were maybe good enough when the internet got started, but are not good enough anymore. And so one of those problems is addressing. Every computer that connects to the internet is essentially like a node on the internet and has an address assigned to it. And that's called your IP address. But the problem with IP addresses on today's internet is that you could know a lot about a person if all you know is their IP address. And every request that comes into you when someone makes a request to your server or to your computer, if you're running a service on your computer, every server sees the IP address of the person making the request. So when you go to Google, they know what your address is. And they can pinpoint your location down to your exact neighborhood, right? So they might not know like the exact house that you're at, but they know your neighborhood, and they can go to an authority and they could get a warrant if they really had a reason to, and they could actually force your internet service provider to reveal which subscriber was connected with that particular address and made this particular request. This is sometimes used to, let's see, I saw Sylvester trying to connect, but then all of a sudden he disappeared. This is sometimes used to figure out if someone committed a crime online, right? But there's also a danger here. It's not just dishonest people that need privacy, right? It's also someone who just doesn't want to be exposed to would-be thieves online, or it's also someone who lives in a country where they lack certain freedoms, where even just saying above board kinds of things related to human freedoms might be threatened, right? So there are valid reasons to have privacy. And what Web3 does, what Web3 technology does, is it starts to use what we call a peer-to-peer overlay, so that the actual location of these individuals who want to talk to each other is not known just by looking at their address. So it just kind of abstracts away that address and uses different means of getting the packets you want to send to one person on the network to another person. The addresses that are assigned to these individuals have nothing to do with their physical location, all right? So that's one thing that blockchain already does that's important. The next thing that's important is that humans struggle to remember numbers. So rather than having to type in a number to go to Google, humans prefer to type google.com. And this is what we call the domain name system. But the problem with domain name system is that it is centrally controlled. So the authorities that decide whether you can get a website address or not they have a lot of power, and they can basically take your site down by just saying, oh, they're publishing stuff we don't like, so we're going to just kick them off the internet, right? And that's sometimes happened. Now, a lot of times it happens just because someone's doing something egregiously illegal or immoral, but sometimes it happens if someone's just like publishing true information that somebody doesn't like, right? So what blockchain does is it substitutes this hierarchical control of these various domain names with a system that uses auctions to determine who gets to own a blockchain. So you can search for a name that you want, and if it's not too popular, you can get it for a reasonable fee. And if no one else bids on that same name, you just get it after a certain delay, right? And as long as you keep paying the fee, you can keep that domain name. And browsers are starting to add this functionality as well, like Brave browser and a few others now support the ability to use Ethereum name service and other services like what is it, like perpetual domains? I can't remember what it's called. Anyway, there's a few other services that permanent domains, something like that, that use blockchain to secure these names. So now you have like privacy and addresses, and now you also have privacy, or you have an egalitarian, non-hierarchical control over names of websites, right? Another really big use case is the idea of self-sovereign identity. So one of the challenges with current identity space is that people are relying on Google, Microsoft, and others to secure their logins. But the problem is that every time you log into another website, Google knows that you're logging into that website. So, privacy is being leaked in that process. They don't know your data necessarily, but they know you're interacting with someone. So imagine, for example, a situation like back in the old days, if you wanted to get into a bar, you just had to show your ID to show you were over a certain age, right? And the government didn't need to know that you went to that bar. No, nobody was like calling up the Department of Motor Vehicles when you show them your driver's license and saying, hey, are you okay with Screven buying a hot chocolate at the bar here? Or whatever it was, right? But right now, with what we call federated identity systems like Google and Microsoft, that is being revealed. Who you're interacting with is being revealed. Another weakness of traditional identity is that right now, if I have to show my ID at some establishment, not only do they determine that I'm over 18, they find out my exact date of birth. So they find out more information than they actually need to know. But self-sovereign identity protocols allow you to do what are called range proofs, where you can demonstrate, you can prove cryptographically that you're over a certain age, but you don't have to reveal what your exact age is in that process. Another example of that would be, let's say that you're applying for a home loan and you have to prove that your income exceeds a certain amount. You could have a credential issued through a verifiable credential system, like what I'm describing here, where your employer could provide a credential to you that attests that your salary is above a certain amount without revealing the exact amount that your salary is. So that's another way that verifiable credentials can be used. In this case, the credential is exchanged between the owner of the credential and the issuer, which would be like a government agency or something. And the credential never needs to be fully revealed to the verifier. The verifier the owner merely sends a proof to the verifier. You have an app that proves something, basically. And then the verifier can just call back to a blockchain to see and make sure that that credential has not been revoked. But once they confirm that it hasn't been revoked, they've already got the proof. They don't need to tell the issuer anything about that so-and-so was talking to me, right? So this is how verifiable credentials work. And these are enabled by blockchain technology. All right, so the obvious use case that's already big is payments. So we no longer rely on these centralized payment systems like banks and credit cards. And now we have the option of using crypto. Another interesting use case is that in communications, you might not know, like you could still encrypt data for some third party, but you might have this weakness where the government sees, or third parties can see that you're talking to somebody else. So it's like they might not be able to decrypt your communications, but they're seeing an awful lot of traffic coming from Screven's house, and they're like, what is this guy up to, right? And another challenge is they might use what we call jamming. signal jamming, which is just like they might not know what you're saying to each other, but they might not want you to say it. So they just like block all the airwaves, or they send a bunch of static that makes it impossible for you to communicate. So in both of these cases, either because they notice a lot of traffic or because they block the line, these are situations that we call surveillance or censorship, right? And you can come up with a peer-to-peer protocol that is censorship resistant by like sending always some nonsense, just some noisy communications that isn't really doing anything, but it's just like background noise. And then hiding your real data amongst the background noise, right? You can also send packets like in a broadcast method where you could, like in this particular example, we're seeing partial addressing where like we don't actually know who a message is intended for. So we just send it as a broadcast to a bunch of nodes on the network. In this case, we're sending a message, AC is sending a message to BC, but they only include B as the address and just leave the rest unspecified. So anyone whose address starts with B should get the message, right? So in this case, AB is like, well, I know how to get that packet closer to its destination, so I'm going to send it to this node here. This node is like, well, I know how to get it closer, so I'm going to send it to this node here. And this is supported by the addressing protocol that I mentioned earlier. In this case, each of these nodes know that they have another node closer to the destination that this address applies to. Eventually, BC gets the address, and only BC has the private key that can decrypt the message. So all of these nodes received that message, but only one of them could actually decrypt the message. So what this does is it makes it harder for a government to surveil that communication because they just see a bunch of stuff going all over the network and they don't know who it's actually intended for. And this is an example of a protocol that is surveillance resistant and censorship resistant. So that's another thing that another thing that these protocols can do. Another thing that you need for typical modern web applications is you need the ability to store data in the cloud and not have to store it always on your own computer, like on your mobile device. You know, maybe your mobile device is going offline all the time. It's losing power all the time. You don't want to rely on it to be the thing that backs up all your data. So we have cloud computing for that. But right now, all the cloud computing is centralized at Google or at Amazon or what have you. Web3 has already begun to offer protocols that allow you to store your data on many different servers, each of which receives a small reward for storing that data. And the data is stored in an encrypted format, so you still cannot read that data. In other words, the people hosting the data can't read the data. But they can return it to the owner when the owner requests it. So this is kind of like a backup service. And you can also specify the redundancy levels of your data. So like if you want to strike a balance between the cost of storing the data and the amount of backing up that you're getting, you can specify like, oh, I'm good enough for this much, and it affects how much you want to pay for that storage. But that is also happening where, like, let's say you're building an application. Now, instead of storing the data on servers you own, you could store it on a peer-to-peer network of servers, and your application users would actually make requests to all these peers saying, give me this data so that I can play this game that someone made or whatever it is. You not only need the ability to store static files like images and documents, but you also need the ability to like randomly seek for data that's more ephemeral. So that's where a database comes in. So you have a database where you say, like, I want to find all the people whose name starts with B or something like that. And in those cases, having to open a lot of static files is not the smart way to do it. You need something faster. And there are some services now that are offering something similar to the storage service I mentioned earlier, where you have multiple nodes that are providing a unified view of this data. And you can query each of those nodes for the data you're looking for and get a result back. And they basically, you get the response. If you have enough redundancy and at least somebody is online and available that has the data you're looking for, you can get the answer back that you need. Now, one of the last pieces you need is you need the ability to actually compute. Like when you're using your mobile device, maybe you want something to happen when your phone is off or when it's not doing anything. Maybe you want to get a text when you've exceeded your budget threshold for the month. Those kind of notifications where something is checking in the background and doing stuff for you require computation. And right now we're paying services like Amazon and Google Cloud and others to do compute for us while we're not online. And the problem there, of course, is that the compute is happening in a central location. Also the problem that some of these places, we're trusting them with our data. They can see our data if they wanted to. But there are new things coming out where jobs get executed by independent peers, and even some exotic new services that use tools that we call, one tool is called homomorphic encryption, which means that you could send your data still encrypted to this person and it could do computation on your data without decrypting it, which is just mind-boggling that that's even possible. That's a very fledgling stage of computation right now, but it will become more and more relevant as people require more and more computation for AI and other things like that. Especially when you consider that AI is one of the most powerful resources right now in the world, and allowing decentralized access and control of AI will be essential for human freedoms in the future, right? So I'm just going to speed through this last part. I just want to talk for a second about incentivization. So I don't want to go into too much detail here because it's already long and I don't want you guys to get too worn out here. But what's really interesting about Bitcoin is most people think that and Bitcoin is the classic blockchain protocol. It's like the first one, right? Most people think that the creator of Bitcoin is already dead. And so the question that one might ask is, if the creator of Bitcoin is already dead, why is it still working? And I think this is a really interesting question. And one answer is that Bitcoin is an incentivized system, meaning that it kind of keeps going on its own because it has incentives for people who want, it provides an incentive for people to interact with it. And here's some rules about how these incentivization systems work. You've got some kind of public utility that anybody can connect to. You have some token associated with that utility that is a system of record for tracking the use of that utility. The system is self-sustaining in that it will keep going even if the creators of the system disappear forever. And if it does something that people actually want, that's the main thing. But what's really weird is when you start to design incentives, you're getting people to do stuff by rewarding them with something that has monetary values. So blockchains are like incentive machines. And he says this guy Trent McConaughey sees this as a superpower. The question becomes, what do you want people to actually do? And how well you can communicate that intent with machines so that they can track those actions. Another guy, Elad Verbin, wrote this really intriguing article called Behavioral Cryptoeconomics. And in this article, he said that he points out that it's actually really hard to create a good incentive system. Bitcoin so far works partly because it's pretty simple and it just does one thing well. But there still are challenges with even Bitcoin. Like a lot of experts predict that in the future, the block reward for Bitcoin, especially when it's all gone, the transaction fees alone will not be big enough to incentivize node operators to keep running their node and doing the proof of work required. So you got this problem there where it might happen that in the future, a lot of node operators say, you know what, it's no longer worth it to me. I'm not making much money, so I'm just going to drop my node, right? And what happens when not as many nodes exist, right? The more nodes that exist, the more decentralized the system is, the more robust it is against attack, because any attacker has to prove to that vast network of other computers that they have a non-falsifiable chain, and they can prove that they were rewarded the funds that they wanted to be rewarded. But if now that number of nodes being run on the network is dwindling and dwindling and dwindling, suddenly the cost of mounting an attack on the network becomes a lot cheaper. And so if we no longer have a good incentive for running the network and the node operator count gets low enough, then that network becomes vulnerable. And when you have trillions of dollars worth of value in the Bitcoin blockchain, that's kind of a scary thing. And a lot of Bitcoin fans are not thinking about this. They're not really thinking about the changes that may need to take place. And Bitcoin is known for being a little bit crusty. Like, those guys are hard to persuade to change and fix things. And so they might not respond in time to the need to upgrade the protocol and increase the transaction fees in order to continue to keep the Bitcoin blockchain secure. So that is one example of how incentivization systems don't always last forever. You could think of a political system like a constitution as a system of incentives also. And we've all seen how a constitution can start out well, and then people can start to figure out ways of abusing it. And so one could argue, for example, that in my own country right now, some of our politicians have figured out ways of abusing the incentives in our Constitution to do things that the founders probably did not intend and would not be happy with, right? So that's just an example of how incentivization systems are tricky to get right. And the more complex your system is, the more challenging it is to make it really sustainable. But these are very powerful systems as well. So they're really exciting to work with. And I just have one final thought, which is this one from a famous podcast host who talks about what's going on in the crypto space, and she says something really interesting. I think I've got a narration of her actually saying it. Let me see if I can find it.
The idea that you can create verifiably scarce digital assets is certainly novel and represents a breakthrough in our history. But I actually think that another, potentially more powerful development is getting little attention. And that is the ability to remake the big businesses that we know today as networks that are decentralized, peer-to-peer, and user-owned. Yes, Facebook, Google, and Amazon are tech giants, and we rely on their products and services day in and day out. So it probably seems hard to imagine a time when they might be replaced by user-driven versions. It seems obvious that a business entity with employees who are motivated by stock options could outcompete any challengers that are being built by users around the globe who are just everyday people interested in this project and aren't necessarily motivated by quarterly performance reviews or by a weekly paycheck. But to remember the power of decentralized networks, just look at what happened between Wikipedia and the Encarta Encyclopedia. The first, obviously, was a crowdsourced version, and the latter, Encarta, was run by Microsoft. But now when you search for Encarta on the internet, the first search engine results is not Encarta because it no longer exists. It's the Wikipedia entry for Encarta.
So that's my final thought for you today, is that what will the world look like when we've replaced these centralized feudalistic havens for our data and for our social media with user-owned alternatives that are incentivized by the token utility that is built into the various blockchain networks that run them. What kind of world can we create when that technology becomes ubiquitous? And that's all I have for you guys today. Any final thoughts or questions?
That was wonderful. I feel like a Bitcoin guru right now. Yes. So my question, like, so for like Web3, um, like they're trying to democratize, like everything and even access. In very lay terms, like would there be like wouldn't like government or like central authority like figures like clamp down on like an open web that is
Yeah, this
doesn't
is
like restrained? Yeah.
this is really interesting because like we do see efforts to do that, especially during like revolutions or political unrest. Um, but what's also interesting is it tends not to last very long, because when you turn off the internet in your country, suddenly like trucks stop knowing where to take their stuff, and the dispatchers stop knowing where the trucks are, and these countries realize that their entire infrastructure operates with these peer-to-peer protocols.
Mhm.
And so the only real way to stop these protocols we're describing is to cut off the whole internet in the country, right? It is possible to kind of like attack the network, to block certain protocols that like to do more targeted blocking, but that's kind of like a game of whack-a-mole, because as they try to block certain targeted protocols, the protocols will just get more sophisticated until you get to the point where it's really difficult to tell the difference between these protocols and any other ones that are being used, right? So I think that this is my personal take on it. It may take a long time, but I think that when these decentralized alternatives become fully mature, governments will have to resort back to what they did before the internet, which is that they tried to infiltrate threats through human systems, right? So you're still going to have people who are engaging in things that the government doesn't like, and sometimes it will be legitimate crimes, and sometimes it will be just, maybe political opponents or some, threat to their authority. But in those situations, they're going to have to hire spies to go and infiltrate your crime syndicate or to go and infiltrate your political party to figure out what you're doing and to try to stop it.
Yeah.
I think it will come back down to some of the the most basic technologies, which we would call like face-to-face communication, or just kind of like, yeah, the things that people have been doing for ages and ages.
Yeah.
So,
Awesome. Awesome. Appreciate this.
yeah. Jonathan, do you have any thoughts on this?
On my side, it was very interesting. So thank you so much for that. It just reminded me these two powerful quotes that I came across when I was also preparing for this meetup. The first one is, it says Bitcoin will do to banks what email did to the postal industry. So that's it came from someone called Rick Folkvinch. I don't really know. I need to study more about him. But it's just see how technology is kind of progressing and how things are getting, like, in a way it could be much easier of interacting and also dealing with situation. And the second one is says we have elected to put our money and faith in a mathematical framework that is free of politics and human error. So that's kind of reminded me. There was a story that was going around here. I don't know if Scriven, you remember it, where there was a student in university who got a deposit of like 20,000 USD in his account, and the bank froze his account. So they are like asking, where do you get the money? What are you gonna use it? Like,
Yeah.
trying to do like a background check to their families and then to see if it's not like a stolen cash and thing. But like, I'm thinking, if just she used another way of doing the transaction and getting all that, she could have been enjoying freely what she has earned or did other things. So politics and the way we use our thing, that's kind of what makes us free. And doing it in a way that gives us much power and control, getting history and making sure we can track our system, I guess this is the best way of moving forward.
Yeah. Yeah, and I would say along those lines, we've seen a lot of enthusiasm for blockchain and crypto in countries where the currency maybe is a little less stable and where people have less trust in their government and their central bank. And so that is especially relevant in places like Argentina, which has experienced lately like a lot of financial challenges. And some African countries that applies to also. But I would also say, for the same reason that I shared at the end of my presentation about incentives and how they can go wrong over longer periods of time, I think it's wise for us to be a little bit careful about assuming, like, it's funny, I do get excited about the promise of some of the things the quotes you shared with us, Jonathan. This idea that, like, blockchain potentially is an upgrade from unreliable human controlled financial systems. But it also can be dangerous in the sense that, like, imagine you're in a train and you've gotten rid of the engineer on the train, right? And you're basically you just say, like, well, we've got all the systems in place and all the incentives that the train will keep functioning properly forever, right? But if you don't have a human in the loop, you can sometimes encounter challenges in the future that you never anticipated, and then it can be somewhat difficult for the very brittle system to adjust to that. And so I think that for many, many jurisdictions, a lot of aspects of blockchain are an upgrade from what people have been accustomed to. But there still is this challenge of like that it needs to be also something we can amend or adjust ourselves. And the current way that that happens in Bitcoin is that the developers all sort of agree amongst themselves that something's not going well and we need to update the protocol. In Bitcoin, that's been hard to do. So sometimes, when there's a challenge, it takes a while and they might be slow to respond. There are other protocols that are trying to improve upon this notion, but with varying success. So that's just something to think about. Is like I like these libertarian promises of like code that just runs itself and is incentivized without humans needing to interfere. But I think there may be some limitations to those promises, and we should just be a little bit careful about that. And one other thing I would add is that like blockchains can do whatever you want. Like if you wanted to create your own communist utopia and have it all run on blockchain, you could. It might not be there might be other inefficiencies and problems with such a system, but it's not absolutely necessary that blockchain technology be associated with libertarian principles. Someone could use a blockchain to more fairly redistribute wealth, or to manage taxation in a way that seemed fairer to them. And it just kind of depends on how they want to manage it. But one really interesting topic that was covered in our meetup in 2022 was this guy who presented on what they call Harberger taxation combined with Bitcoin and or with crypto. And in this model, it was like this idea that like, what if your taxes were self-declared? Harberger taxation is this idea that you rely on citizens to declare what the value of their property is to determine how much they're taxed, right? But you also add this rule that anybody who wants to buy your property can buy it for the value you've declared. And they're given like an auction period where they bid on the property, and then if you can come up with the difference in taxes for the value that they're offering you, then you keep the property, right? But if you can't, then the property goes over to them. You get whatever money they offered for the property, but it transfers to them. So imagine then this system where all of this kind of stuff is managed on a blockchain. It would be like amazingly efficient, where all your taxes would be just right there, and the money would change hands automatically, and the taxes would go to the public coffers with perfect clarity and cryptographically provable transactions, that everything was done in an honest way. And I think those kinds of systems have a lot of promise, and there's really no reason why a specific set of rules has to be can't be implemented in a blockchain. By the way, maybe before we go, I'll share with you one scripture that I think maybe applies to our discussion here. Yeah, here we go. Teach ye diligently, and my grace shall attend you, that you may be instructed more perfectly in theory, in principle, in doctrine, in the law of the gospel, in all things that pertain unto the kingdom of God, that are expedient for you to understand, of things both in heaven and in the earth and under the earth, things which have been, things which are, things which must shortly come to pass, things which are at home, things which are abroad, the wars and the perplexities of the nations, and the judgments which are on the land, and a knowledge also of countries and of kingdoms, that ye may be prepared in all things when I shall send you again to magnify the calling whereunto I have called you, and the mission with which I have commissioned you. So what I like about this scripture is that it's not only encouraging us to study the things of God, but also just things all over the world, things that are happening, lots of different subjects and topics, to be curious people who learn how a blockchain works, even if they may never actually code their own blockchain, right? And the work that we do to share these kinds of ideas and to talk about what's going on in the world is actually a really important thing that is not just an optional hobby type thing, but also something that God has asked us to do that will prepare us more for whatever God has in store for us. So that's the thought that I'll leave you guys with today. But you brought some great questions to the table, and thanks a lot.